of these negative numbers, negative decimal numbers. Now here we had to know that we had to notice one thing, that is the answer should be in 16 bits, because here that means that n integer is equal to 16. Now in order to find out the negative binary numbers, what we have to do is we have to convert the positive value of this into binary first, and then we do the 2's complement. 2's complement is equal to negative value. So let's go ahead and do that. So if I go and do for the A part, in the A part we have 17,000, negative 17,535. But first I had to find out the positive 17,535. To find out the positive 17,535 in binary, we divide this one by this one by 2 until we get 0. So I'm going to start from 17,535 divided by 2. That gives us 8,767 and the remainder of 1. And then 8,767 divided by 2, that gives us 4,383, and the remainder is 1. And 4,383 divided by 2, that gives us 2,191, and the remainder is 1. And then 2,191 divided by 2, that gives us 1,095, and the remainder is 1. And then 1,095 divided by 2, that gives us 547, and the remainder is 1. 547 divided by 2, that gives us 273, and the remainder is 1. And then 273 divided by 2, that gives us 136, and the remainder is 1. And then 136 divided by 2, that is 68, and the remainder is 0. And then 68 68 divided by 2, that gives us 34, and the remainder is 0. And then 34 divided by 2, that is 17, and the remainder is 0. And then 17 divided by 2, that is 8, and the remainder is 1. 8 divided by 2, that gives us 4, and the remainder is 0. 4 divided by 2, that is 2, and the remainder is 0. 2 divided by 2, that is 1, and the remainder is 0. And then 1 divided by 2, that is 0, and the remainder is 1. Now we have to read this one from bottom to top. Okay, that is 1 0 0 and 0 1, and then 0 0, then we have 7 1. Okay, so the answer should be in 16 bits. Let's see how many. We have 4 bits right here, and another 4 bits, that's 8 bits. 8 plus 4, 12. 12 plus 3, 12 plus 3, 50. So we had to add one more bit to make it a 16. So I put a 0 in front. Now this is a 16-bit number, but this is a positive. We did it for the positive 17,535. Now we have to do the 2's complement to find out the negative representation of this binary number. But before you turn into negative value, it's better to put all the bits necessary. Like here, if they mention 16 bits, better to change it first, then convert it. If you do conversion and try to put the bits, you're gonna get the answer wrong. So whatever the integer, like how many bits required, like however the bits required, you have to put that first and then start the conversion. Now to 2's complement is basically we do the 1's complement first and then we add 1 to that. That's 2's complement. So here this is 0, so this is going to turn into 1, and 1 will turn into 0, 0 turn into 1, 1 turn into 0, 0 to 1, and 1 turn into 0. So 7 zeros, right? And if you add 1 to that, that is a 2's complement. So it's going to be the exactly the same, only the last digit is going to change into 1. So we are going to have 1 0 1 1 1 0 1 1 1 0 0 0 0 0 0 and a 1, and this is equivalent to negative 17,535, and that's the answer for the A part. Okay, now let's go ahead and hmm, I have to double check if the answer is right. One zero triple zero. Another triple zero. Okay, answer is answer is right, and double check here as well. One zero one 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 0 1 1 1. Yeah, so this is what we exactly derived. Okay, now let's look at the B part. In the B part, we have negative 19,583. Negative 19,583. Same process. First, we find out for the positive 19,583 by dividing this number by 2 until we get 0. So let's do that first. 19,583 divided by 2, that gives us 9,791, and the remainder is 1. And the 9,791 divided by 2, that gives us 4,895, and the remainder is 1. 4,895 divided by 2, that gives us 2,447, and the remainder is 1. And then 2,447 divided by 2, that gives us 1,223, and the remainder is 1. 1,223 and divided by 2, that gives us 611, and the remainder is 1. And 611 divided by 2, that gives us 305, and the remainder is 1. 305 divided by 2, that gives us 152, and the remainder is 1. And then 152 divided by 2, that gives us 76, and the remainder is 0. And then 76 divided by 2, that gives us 38, and the remainder is 0. 38 divided by 2, that gives us 19, and the remainder is 0. 19 divided by 2, that gives us 9, and the remainder is 1. And then 9 divided by 2, that gives us 4, and the remainder is 1. And then 4 divided by 2, that gives us 2, and the remainder is 0. 2 divided by 2, that gives us 1, and the remainder is 0. 1 divided by 2, that gives us 0, and the remainder is 1. Okay, so once we get this, we stop right there. Read from bottom to top. That is 1 0 0 1 1 0 0 0 1. How many ones? 7. Okay, let's make sure I'm dealing with the second one. 19,503, 19,500. Okay, let's see how many bits. 4 bits, 8 bits, 8 plus 4, 12, 12 plus 3, 15. But the question is requiring us to give us the answer in 16 bits, so we add one more bits right here. And then now we have to do 2's complement to represent the negative. We just the positive of this. Now to represent the negative, we have to do the 2's complement. To do the 2's complement, first we have to do the 1's complement. That is, we turn the zeros into ones, ones into zeros. This is 1 0 1 1 0 0 1 1 1 0 0 0 0 0 0 0. Now we have turned into one's complement, then add 1 to that, that is 2's complement. So 1 0 1 1 0 0 1 1 1 0 0 0 0 0 0 0 1. And that is our final answer. Okay. 1 0 1 1 0 0 1 1 1 and 7 zeros. Now we have done with the B part. Let's do the C part. The C part, we have 9,251. That's that. negative 9,251. Okay, as we did before, we had to find out the positive value of this first, and then we had to convert this one into 2's complement. So positive value, we divide this one until it becomes 0. So 9,251 divided by 2, that becomes 4,625, and the remainder is 1. And then 4,625 divided by 2, that becomes 2,312, and the remainder is 1. 2,312 divided by 2, that gives us 1,156, and the remainder is 0. 1,156 divided by 2, that gives us 578, and the remainder is 0. 578 divided by 2, that gives us 289, and the remainder is 0. 289 divided by 2, that gives us 144, and the remainder is 1. 144 divided by 2, that gives us 72, and the remainder is 0. 72 divided by 2, that gives us 36, and the remainder is 0. 36 divided by 2, that gives us 18, and the remainder is 0. 18 divided by 2, that is 9, and the remainder is 0. 9 divided by 2, that gives us 4, and the remainder is 0. The remainder is 1 actually. And then 4 divided by 2, that is 2, and the remainder is 0. 2 divided by 2, that is 1, and the remainder is 0. 1 divided by 2, that is 0, and the remainder is 1. So we go from bottom to top here. So 1, okay, 1 0 0 1, 4 zeros, 1 0 0 1, and then 0 0 0 0, and then 1 triple 0 1 1. Okay, 4 bits, 8 bits, 12 bits, 16. No. 4 bits, 8 bits, 8 plus 4 12, 12 plus 2 14. Okay, 4 8 12, and then 12 plus 2 14. So make this one 16 bit. We add two zeros for this because the answer is recorded in 16 bit. Now we take the ones complement. That's basically we convert zeros into ones, ones into zeros. So 1 1 0 1 1 0 1 1 1 1 0 1 1 1 0 0. And then if we add 1 to that, that's the twos complement. So this is 1 1 0 1 1 0 1 1 1 1 0 1 1 1 0 1. And that is our final answer. I hope you guys find this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.